All right, the next example I'm going to show you guys is how to solve for the gravitational force or spring constant using the simple harmonic equation. A spring vibrates about an equilibrium with a mass of 15 grams. If the frequency of the spring is 3 vibrations per 5 seconds, what is the spring constant? So the first thing you do is you want to identify your knowns and what your unknown is. Okay, we were given that the spring vibrates and has a mass of 15 grams. And I already know that the units that we are going to need to use are going to be in kilograms. So I'm going to go ahead and convert this 0.015 kilograms. This is a very common mistake to leave this into grams, and one that I hope you'll avoid by trying to remember, always convert to kilograms. The frequency of this spring is 3 vibrations per every 5 seconds. And so to calculate what the frequency is, what I'm going to do is I'm going to simply type in 3 divided by 5. Okay, so the frequency is at 0.6 hertz. Remember, it's the number of vibrations over time. That's a definition. And so to calculate it, you just divide the two numbers. They want us to find out what the spring constant is, and my variable is going to be K. All right, because this is a spring, I'm going to use a simple harmonic equation, and that states that the period is equal to 2 pi multiplied by the square root of the mass divided by the spring constant. Okay, we are not given this, so I'm going to have to take one additional step to calculate it. I'm sorry, we're not giving the period, and I'm going to use the frequency. Period is equal to 1 over f. Now on the calculator, the easy way to do that, we still have the value showing on the screen. There is a button that you can use that will make your life easier, especially coming into this next section. It is right here above the x squared. It's called x to the minus 1. When you hit it, you will see ANS raised to the minus 1. And what that does, it puts it over 1. Or I'm sorry, put 1 over that number. You don't have to type it in. Hit enter, and that is the period, 1.66667 seconds. Whoops. All right, so now what I'm going to do is I'm going to take the numbers and I'm going to plug them into the equation where they belong. All right, we've got 1.6667, and I'm going to leave this rounded on paper, but I'm not going to round it on the calculator. This is equal to 2 pi multiplied by the square root of the mass, and the mass is 0.015 divided by k. And I think this is where students end up having a lot of problems, is because they don't know how to isolate k and get k by itself. Okay, at this point it's just simple mathematics. I'm going to try to type it myself, and first thing I'm going to do is get rid of this 2 pi. Now because it's being multiplied, the opposite of multiplication is division. So I'm going to divide this side by 2 pi. That will cancel this out, but whatever you do to one side of the equal sign, you must do to the other. If you don't put that in the calculator, you will get errors. You will get order of operation issues. So I'm going to take that number, 0.6667, and all I'm going to do is hit the division symbol. And when I do that, your calculator will take the previous answer and plug it in. We are going to divide this by parentheses 2, and then you're going to hit second, and your pi button is right here where this caret is. When you hit enter, it'll give you a value. So I'm going to go ahead and write in my value, 0.265258238. Remember, you don't want to round too early. You will get rounding error. This is equal to the square root of 0.015 over k. The next step to do to simplify this further is to get rid of that square root symbol. All right, the opposite of square root is squaring. So what I'm going to do is I'm going to square this side to cancel that out. But remember, whatever you do to one side of the equal sign, you must do to the other. Okay, let your calculator save all the decimals in. All you'll need to do is just hit square, and it'll take that previous answer and square it. So I get 0.0703619,331 equals to 0.015 over k. At this point, a lot of students will make the mistake of multiplying those two numbers to solve for k. When your variable is on the bottom of a fraction, and only when it's on the bottom of a fraction, the easiest thing to do would be just to switch these two out. Mathematically, that's what you end up with. So, if I do that, I get k equal to 0.015 divided by 0.0703619,331. This I simply enter into the calculator by typing in 0.015 divided by second, this button up here, and then if you hit the negative sign, it'll take your previous answer, and you won't have to worry about rounding error or missing the decimal. Once you type in enter, you'll get a value of 0.2, and your units would be Newton meters. And that's it.